Hey guys, today's topic is related rates. Related rates problems involve finding the rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. In other words, you're finding the value of a derivative using other variables that you are given in the word problem. I'll break down the steps that are useful for related rates problems. First, draw a figure and label quantities. Second, determine known and unknown values. Third, find an equation relating the known and unknown quantities. Fourth, differentiate both sides with respect to time and evaluate this derivative at the approximate point. Did you guys get that? Let's dive into an example problem. The first problem that I have states, a rocket is rising vertically at a speed of 300 meters per second when it is 800 meters directly above the launch site. Calculate the rate of change of the distance between the rocket and an observer who is 600 meters from the launch site and on the same horizontal level as the launch site. So first, draw a figure. In this scenario, I'm going to draw a right triangle. The launch site is going to be at the origin, the y-axis is going to be where the rocket is, and the x-axis is going to be where the observer is. I'll label y as 800 and x as 600. Then determine the known and unknown values. We know that y equals 800, dy over dt equals 300, x equals 600. But we don't know the value of d, the derivative of d, and the derivative of x. In this case, we're finding the value of dd over dt. Then, find an equation relating known and unknown variables. Because we drew a right triangle to represent the situation, we're going to use the Pythagorean theorem, which states x squared plus y squared equals d squared. First, we're going to plug in the values of y and x to find d. 600 squared plus 800 squared equals d squared. And then I did the calculation and d equaled to 1,000. Since we're not given dx over dt, we're going to plug in the value of x into the Pythagorean theorem equation. So I'll get 600 squared plus y squared equals d squared. Then we take the derivative of both sides. The derivative of 600 squared equals to 0 because it's a constant. The derivative of y squared equals to 2 times y times dy over dt. And the derivative of d squared equals to 2 times d times dd over dt. Then plug in the rest of the values. 2 times 800 times 300 equals 2 times 1,000 times dd over dt. And then I did the calculation again, and dd over dt equals to 240. So your answer is 240 meters per second. I have a second problem for you, and it states, the height of a circular cone is increasing at a rate of 6 centimeters per second. The radius of the circular base is decreasing at a rate of 1 centimeters per second. Find the rate at which the volume of the cone is changing when the height of the cone is 12 centimeters and the radius of the base is 3 centimeters. So first, draw a figure and label the quantities. I'm going to draw a right circular cone and label the height as 12 and the radius as 3. Then we're going to determine the known and unknown variables. We know h equals to 12, dh over dt equals to 6, r equals to 3, and dr over dt equals to negative 1. The reason why it equals to negative 1 is because it states that the radius of the circular base is decreasing at a rate of 1 centimeters. So it's important to make sure you put that negative in front. Then we don't know the rate of change of the volume, so we're going to solve for it. Find an equation relating known and unknown variables. we're going to use the equation that finds the volume of a cone, and it is the volume equals pi times r squared divided by 3. Next, take the derivative of the volume equation, which gives us dv over dt equals pi over 3 times parentheses 2 times r times dr over dt times h plus r squared times dh over dt, and close the parentheses. If we plug in all the values we know, we will get dv over dt equals pi over 3 times parentheses 2 times 3 times negative 1 times 12 plus 3 squared times 6, and close the parentheses. And then at the end, we get negative 6 pi cubic centimeters per second as our answer. So that's the end of today's video, and I hope it helped you better understand related rates. Thank you.